Even in modern automatic packaging machines, blank feeding is a repetitive task currently carried out by humans, making it quite inefficient. The palletization is done by a robot in a cage in a very controlled and structured environment. To develop a solution for autonomous blank feeding for packaging machines, an industrial environment has been set up in IMA installations. In this field test, the robot has to recognize two types of blank piles on 3 pallets, devise a plan for picking them, transport and place them in blank magazines of 2 different machines. The workspace is assumed to be shared by humans and the robot. The robot starts by scanning the environment. A fusion of RGB and depth information is used to detect the pose of the pallets, blank piles, and also the pose of the blank magazines. Considering the packaging machine's blank consumption rates and the current blank level at each magazine, the robot devises a plan and selects from which pallet to pick. If more than one pallet exists with the same type of blanks, the robot will select the one with fewer piles. Using a single arm, the robot has to pick 2 different kinds of blank piles. This requires navigation planning and arm motion planning for picking and placing the blank piles. These piles are 15 centimeters high and can weigh up to 5 kilograms. The robot waits for the feeder level to reach a low threshold that allows a new pile to be placed. To cope with the localization error of the platform, in the magnitude of several centimeters, the feeder relative position must be detected and corrected by recognizing a known pattern in a marker. The blank is then placed on the feeder in a smooth controlled motion, in order to ensure that machine running conditions are not disturbed. To continue feeding the first machine, the robot proceeds to the next available pallet. The pose of the blank piles is detected by a fast pattern matching algorithm that takes less than 1 second. During operation, the operator can monitor the process on the operation dashboard. Among other things, this dashboard shows the blank feeders level in real time, the current running plan, and the visual detection of pallets, piles, and markers. In this part of the demonstration, a second machine is turned on. This forced the robot to automatically replan the tasks to perform. The second machine's feeder includes a conveyor belt that is able to accommodate more than a single pile of blanks. In this case, or whenever there is enough time, the robot can pick up 2 piles in sequence, carrying the first one in a dedicated buffer and the second one in the elevated platform used to perform the pile flipping. The robot proceeds to feed the second machine feeder. Note that both picking and placing positions of the blank pile are different between feedings. The feeder level is indicated on the dashboard. Due to limitations of the current arm reach, removing the last pile on a pallet, the one on the center of the back row, requires more than one step to perform the grasp. The robot has human tracking capabilities, and for safety concerns, the presence of a human in its vicinities triggers a generalized motion stall. Also, tracking humans allows the robot to pay attention to any gesture commands issued by the operator. For safety reasons and during development, both the robot and the arm velocities were kept significantly conservative, leaving plenty of space for speed optimization. Even with these low operation velocities, the robot would be able to feed at least 4 machines, which turns this solution economically viable.